So I'm gonna click on graphing calculator using Desmos. Okay. If I have this equation x plus y being equals to 1, what kind of equation is this? What kind of graph is this? Class? What kind of graph is this? This red line, what does it represent? A straight line. So this is a linear equation, okay? And if I decide to make this x guy, if I decide to square it, this becomes a quadratic equation, okay? What about if I decide to square y as well? What do you see here? Tyler, what does this represent? The red shape. Okay, this represents a circle. So this is how we're gonna be drawing circles. And then if I go downward, as you can see, this red circle here, it's has a radius, and the radius is only this distance you move. The radius is when you move from, this is the center of the circle. The point from which, you have the same distance when you go to each part of the circle is called the center. And then here, the distance from the center to each part, one part of the circle is called the radius. So as you can see here, the radius here is 2. Even if you go two step forward, 2 step backward on x-axis, 2 step downward, and 2 step upward on y-axis, it's always the same, 2. And
Wouldn't that be 1?
oh, sorry, that's true, because sorry, because this is 2 here, so that would be 1. My mistake was that I was thinking this is 1, 2, and then 3, 4. Thank you for calling my attention to that. So here the radius is going to be 1. Then if I decide to increase the radius to something like 4, if I decide to have x squared plus y squared being 4, here what do you notice? Here the radius becomes, since the center is at the origin, and then the radius becomes 2. Whereas in my equation I have 4 here. So which means the equation of a circle is always the square of x and y components, then the square of the radius. If the radius is r, you have to square it. So 4 comes from what? 2 squared. That's why the radius here is 2. So if I decide to go further by drawing another circle, let me say I have x squared plus y squared, so that it gives me, I want to have a circle of radius 3. So what do you think I'm going to put in front of equality sign? If I want to have a radius 3, what should I write in front of this equality sign? 3. No, since
9.
9. The radius square. When you write the equation of a circle, you have to always take the radius square, okay? So if you say 3, you gotta take it to the square, okay? The square of 3 gonna be 9. Then if I have this, I have these 2 circles. So these 2 circles are called what? Since they have the same center here, they are called concentric circles. As you can see here, this guy, all of, the red circle here has a center at the origin, and the radius is 2. The green circle too has a center at origin, and the radius is 3. So since they both share the same circle at the same center, they are said to be concentric circles, okay? Then how do you label the center? I think those are things we've done before. For the labeling, you just come down, open your bracket. Since the center is at 0, 0, close your bracket. And once you click here, it's going to label it for you. And if you want to draw a radius, you're just going to say, let's take x being equals to 0. And then try to reduce the size of x. So I'm going to just open this. And then I'm going to start from 0. I want us to get the radius of the red circle and the radius of the green circle, okay? So I'm going to move 0 less than x, or less than y, then less than 2, and then close it. As you can see, I have the radius on. Anyway, is it possible to change color? No, it doesn't give me any color here. And then if I want to draw the radius of the other one, it's just to say y being equals to 0 as well. And then try to open curly brackets. From there, I'm going to move 0. I'm going to say 0 less than x, then less than 3. Doing so will give me this. So as you can see, we have two circles here with the same center. And when two circles have the same center, they are said to be concentric. And there are situations to where you can have two circles such that, you know, they will share the same tangent. The tangent of a circle, okay, I'm going to also show you what tangent means. Tangent is usually a line that goes through the side of the circle without passing inside it. So if I have a point here, I have a line going through this way. This red line is called tangent. Okay, a tangent, line of tangency. So we have many of them. You can draw as you want. So if I want to get one tangent line at 3, I might just say take x to be maybe -3. If I say x being -3, I have a line of tangency here. I might just try to reduce the height to make it something smaller than everybody can see. If I just say from -4 less than, since I'm dealing with y components, because I want the y component, since this red line goes through y, it goes through, you know, x. So it means I want to shorten it, you know, in terms of the y size, okay? So I'm going to put 4, close. So this blue line is what we call line of tangency. So this is a tangent. And I might also try to draw a chord. A chord is just a line that passes through 2 points, you know, in the circle. So if I have a line that passes through here to here, this red line is called a chord. Okay. In the right triangle to circle, so I can have a chord somewhere here. And then the longest chord is called a diagonal. So the longest chord has to pass through the radius. So 2 radii gives us a 2 radii will always give us a diameter. The diameter is the longest chord in a circle. So these are things you're going to see on Monday. And aside that, I'm also going to write another thing else. Okay, and another way is if you want to move your circle far away, these are the things you do. It's better you open bracket, you put x, close bracket, raised to power 2, then come down, plus open bracket y, close, raised to power 2, oh, sorry, come down equals to, if I say maybe a circle that is of radius 4, then I want to shift that green circle far away, okay, towards the left hand side. So to move that one toward the left-hand side, I'm gonna write x minus x plus x plus. Maybe if I want to move it towards 8, can I? Okay, let me see 6. Okay, I move it around 6. Okay. Then I want to also move y downward. So I'm going to put plus 6. Okay, you see the circle right now down here. Because the general equation for moving a circle, let me copy this work here. Control copy. Then when I come down, the general equation of a circle is always x minus h, then y minus k, where h and k are the centers of the circle, okay? H and k are always the center of the circle. Okay, Oliver, no problem. So h and k here are the center of the circle. So whatever you do with h and k, it depends on, so if you put a positive number, maybe 3 or 4, and you put a positive number as k, maybe 5, you see, the circle definitely moves. 4 means you have shifted the center. I'm going to show you. That means you've shifted the center. Maybe let me put it in blue. This center was here. Since you wrote 4 here, so it means you shifted the center 4 steps upward on the right hand side. Okay, and then you put 5 here, means you've shifted the center 4 steps, 5 steps upward. So 5 steps here. So when you join these 2 lines here, this, the new center is here, and the new center becomes what? Coordinate 4, 5. So here, x minus 4 square plus y minus 5 square equals to 4 means we have a circle at center 4, 5 with a radius 2. Okay, so this is a circle that is centered at coordinate that is centered as 4, 5 with the radius 2. So a circle that has center of coordinate 4, 5 and with the radius 2. So here, then if I decide to maybe have another circle that is next, Control V. If I decide to have a circle that will be inside this, so let me take maybe the coordinate 2. If I take radius 4, okay, radius 2, then I want to make sure I shift this guy. For me to be able to shift, I want to shift this circle here. I want the center to come somewhere here, okay? So that this black side, this side and this side are going to be together. So I have to decide the x component of this. This x component of this is minus 5 here, and the y component is minus 6. So it means instead of 6, I'm going to put minus times minus is what? Plus. So I'm going to put plus 5 and the other side plus 6 and see what's going to give me. It moved a bit far away from it. So if it comes here, the radius is going to be somewhere here. So I needed to shift it a bit down backward again. So if I do it with 5, it makes it backward.
Did you take attendance already?
Yes. So where's the major equation? Okay, 6. Okay, so as you can see here now, we just came and so that I can put your name on attendance. That's Oliver. So as you can see here now, this is the work. Let me clean this. So as you can see, these equations, these two equations, the green here and the black here. So here, as you can see, both of them have different centers. If I put the center of this guy here, the center of this equation here, the equation with 6 means the center is at -6, -6. Close. This is the center of the green triangle, okay? That's the center of the green triangle. And then for the green circle rather. So this is the center of the green circle, since the equation is +6 + 6. So it means plus minus times minus is plus. That's why I'm having minus here as x component and -6 as y component. So then I'm gonna also draw the center of the second one, the black circle. So the center here, since I have x + 5, that means minus times minus gives me plus. Then the x component gonna be -5. And then the y component, since I have +6, that means minus times minus is plus. So I'm gonna have -6 as well. When I close, you see the center of the second one. The blue one is the center of the black circle. But what do you observe? I'm gonna draw a line. The next thing is the line of tangency. So if I draw the tangent, so the tangent is at this point. This looks like 4 points. Let me say 4 point something. X equals to -4. So let me shift it a bit, -3.8.6. Okay. And then let me try to reduce the size. So from maybe -10 less than y, then less than maybe -2, so as not to go far. Okay, so as you can see, these two circles here, the black and the green, have the same tangent line on the left hand side here with coordinate -3.6 and -6.2. So here, since the black circle is inside the green circle, so and the tangent point is, and both of them have the same tangent line, then here we talk about internally tangent circle. Internally tangent circle means one circle is inside the other, and then they share the same tangent line. We also have external tangent circle. So if I decide to draw maybe another circle, let me Control V. I want to have a circle that will still touch this guy at -3.6. So if I put +3.6, x 3.6, 3.6. And then let me go far away. And y remaining the same, but if I want to have a circle, that this time around, that means I'm not gonna definitely have a circle so that the center would be somewhere here. So the center would be at 2, and then x being 2, and x being -2, y being -6. So 2 -6. It's a delicate job, so it's really needs your patience. And 2, let me put 2 here. 2 -6, but it's still bigger. So the radius gotta be, what was the radius of the guy? Okay, let me put radius 2. So I need to shift it a bit backward. So 3.6 still inside it. If I put 2 here, 2.2. Okay, it's sitting on it. So as you can see, this purple triangle, this purple circle, why am I saying triangle? Because the previous chapter talks about triangle a lot. So here, as you can see, the black circle and the purple circle are sharing the same point of time, the same line of tangency. Okay, so here we say since the two circles are outside each other, so they are called external. And then to say since they share is the same tangent line, so they are called external tangent circles. So these are the things we're going to see really on Monday by God's grace. So we're able to see, and here if you want to get a diameter, here for this particular purple triangle here, the purple circle, the diameter just going to be a line that will pass through the center and then cut it, that will be the longest chord, the line that will pass through the center, okay, and touch the circle on 2 places. So if I want to draw the diameter, I'm just going to say y equals to, since the y component here on the center here, as you can see here, is -6. So I'm going to say y equals to -6. Then I have to reduce the size so as to see what we're talking about. So since the smallest x component there is -0.2.2, and then I'm going to put x, and the biggest component going to be, I think, 1 point something, 1 point, let me say 1 point, 3.6, 1.2. So 1 minus 1.2 is too small, 0.4 or 0.8. Okay, as you can see, this black line here, inside this purple circle is called diameter. The diameter is the longest chord in the circle. It divides the circle into 2 equal sides, okay? So a diameter in a circle is like a line of symmetry, because if you fold the upper level of this purple circle downward, it's gonna be the same size as if you cut into soccer ball, a soccer ball into 2 halves, okay? So that's what we have for ourselves today. So if you really want something for yourself in terms of grade, I'm not just gonna stress you, just draw a circle for me and bring it to me. You know the equation of a circle? Make sure you have x squared plus y squared equals to something, and then take a screenshot and send it to me. So these are the beautiful things we've done today. So let me take a screen and then send. Okay, let me stop the record. What was I recording this thing? Stop.